Yeah, I'm starting to share the screen. Yeah, I'm starting to share the screen.
The light is on.
Yeah, and the camera is here.
Cool. Oh, do I have to stay in front of the camera, or can I walk around?
They'll just not be able to see you if you walk around, but
That's
it's okay. It's
All
okay.
right. They can hear me.
They can hear you if you're not too far away from.
Oh, okay. So
Yeah,
like,
but if you bring a mic and you're low enough, it should be okay.
so is it just that mic or this mic?
Either one.
Okay.
Yeah, this one. I'm going to use this one
Okay.
for students' questions.
Oh yeah, sure.
That is not the right screen. Yes. And right screen. Yes. And right screen. Hello everyone. Welcome to the lecture today. So today's lecture is not presented by me or Hayden. So today's lecture is presented by Nick. Hello everyone. So today, let's give some warm lecture today. So today's lecture is not presented by me and Nick will give some more detailed introduction by Nick. Hello everyone. So today, let's give some warm lecture today. So
Hi everyone. Good morning. What a miserable morning it is. I'll try and keep up as best I can. After all,
let's give some warm lecture today.
Hi everyone. Good morning. What a miserable morning it is. I'll try and keep up, and then I'm going to talk about continuous integration. After all, those are some funny words there, but hopefully by the end of 2 hours. Hi everyone. Good morning. What a miserable morning. We're kind of so talking about continuous integration. After all, those are some funny words there, but hopefully by yeah, as I said, I work at Atlassian as a software engineer. I went to UNSW. I lived here for 3 years on campus. I tutored for a number of years at CSE, and I graduated at the end of last year. So I've been working at Atlassian for getting on about 8 months now. And 1531 is a very important course to me because it was the very first course that I took at university. 2020 term 1. I took it and I sat in the front lecture row with all my friends and watched the lecturers talk, and it was great. And yeah, some very, very fond memories there. And then in term 3, I got hired as my first tutoring job. I was a tutor and then ended up being a course admin, and then did a bunch of stuff in a bunch of other courses. And yeah, 1531 is very, very close to my heart. A lot of my quite close friends that I have today, I met in 1531. I also worked with UCHOW quite a bit in the past. We published a research paper last year on software engineering education. You guys are at the start of your sort of software engineering journey. This is the first course and it's super exciting. Who here studies a software engineering degree? Fantastic, good stuff. Don't drop it, stay through to the end, you will not regret it. You'll probably see me or stuff that I've done in future courses. I had a lot to do with the software engineering workshops over the past couple of years. You guys all are going to have the pleasure of taking a course called COMP1531 at some point in your degree. I had a lot to do with that as well. So I guess this is not the last you'll probably see of me. But enough of that. Why am I talking to you about TypeScript? I spend most of my day, I was just working on some stuff out here before, talking to UCHOW and showing her. I spend most of my day writing TypeScript and dealing with continuous integration pipelines. So they're probably the two of the topics I have a fair amount of experience with in industry. But But I also today want to share with you some of the theory and the academia behind these concepts as well, because what we're going to talk about is, it's kind of interesting for you guys because you're at the start and so you don't know what's ahead, but I don't know if you've ever read like a book or watched a TV show or a movie and there's this bit at the start and that ends up being really important for stuff later down the track. The stuff we're going to talk about today, and more broadly, everything you're learning in this course is a kind of smorgasbord which gives you little tastes of things that you're going to go study in much further depth in the future of your degree. So we're going to talk about static verification today, which is at the foundation of a whole lot of courses in the future that you may or may not do. Some of them are elective, some of them are core. But I guess, I always like the pitch line of like, why should you pay attention to this lecture and not just like sit there and work on your lab or your project or TikTok on your phone. And for today, it's because if you understand this stuff, you will understand stuff later. And also, it is at the bedrock of what software engineers do every day. The kind of overarching theme for the next 2 hours is quality and risk and assurance, and we'll talk about that in depth. So we're going to talk firstly about risk and software safety and other big picture items, and then I'm going to introduce you guys to TypeScript. This is also a lecture to pay attention to because from what I understand, you guys have to write TypeScript at some point in the near future. So understanding how to do that, it might be quite helpful. That's all I kind of wanted to say, other than, I would think of this as the beginning to a long series of ideas that you will be exploring in your degree related to how do we make sure that our software is correct using static verification. Okay, before we get into that, I want to tell you the story about how I broke my wrist. Mainly because Yu Chao asked me, and I said, you've got to wait until the lecture because I'm going to tell everyone. Do you have the little pointer? Oh, they lost the pointer. Last time I was here, they had a really cool pointer thing that I could use to point at the screen. Damn it, that's annoying. Okay. I really like going skiing. I go skiing with a friend of mine that I met tutoring COMP1531. And about getting on a month ago, I went with a friend to Perisher. Is anyone else a skier here? Yeah, nice. Where do you go? Throatbow. Okay, cool. And someone else here? Throatbow. Okay, cool. I'll have to try that out sometime. Skiing is great fun, but it's a bit risky because you're going quite fast, you're going downhill, and in my case, just to take you on a quick detour about skiing, there are these like different types of runs on the ski fields, and so some of them are like harder and some of them are easier. And I'm not that good at skiing. I just kind of enjoy it, and I can do sort of the green runs, which are like the easy runs, and then there's the blue runs, which are a little bit harder, and then the black runs are like impossible. So I went at the start of September, and at the start of September, the snow's kind of starting to melt. It's becoming a bit more icy, which is a bit more dangerous. There's not as much stuff open, so most of these trails were closed. Anyway, that picture from the slide before is taken out here at this place called Blue Cow. Where are we going? Here we are. And I went there with my friend, and there were only blue runs open, so I could only do stuff that was a little bit harder. All the easy stuff was closed. So we went down here, and then we went up this chair at the top of the mountain, and then I went down this run called Accelerator. And if you notice here, there's these little two squares which show it's like an extra hard blue run. And what that means is, don't do this if you're not that experienced. Now, I didn't know this was one of those extra hard ones when I did it. I just thought, yeah, this is a good idea. Turns out it was not so good of an idea. So I fell and tripped and landed on my wrist, and that's how I broke my wrist. Anyway, you're like, why is this guy telling the story about his skiing hobby? The answer is because when it comes to a lot of things, sometimes you know going in what the outcome might be. So for me, it was like, there's this double blue run, Nick's not that good at skiing, he's not that experienced, the snow is a bit icier, which makes it a bit more dangerous. There are all these conditions going in, which essentially mean that the risk of something going wrong is greater. And the same thing applies to software engineering. I have this quote here, which is, good software design is all table set. People make a lot of mistakes, and I see this a lot. I actually see this a lot in courses now, given my experience in running courses over the past few years, where people do stuff and it goes wrong, and I go, I could have told you that up front because certain preconditions are more risk averse. Like you're going down the double blue run, so it's probably going to be more likely that you're going to fall and and break something. So when it comes to building software, sometimes you go in already having won or lost the fight. Now what I mean about this is sometimes stuff goes wrong, right? In software we have this thing called risk. And I want to differentiate between risk from threats outside and risk from threats inside. We're not going to worry too much about security today, but I want to make this distinction of software security is the practice of protecting your software from bad people who want to misuse your software. We're talking about software safety. Oh, feel free to stop me if you've covered this already. Oh, you covered this last lecture. Okay, cool. You get a recap from me. Safety is about protecting your software from accidental misuse. Often, and Yucha's probably said this, is that the biggest threat to your software is often you as the programmer, because people make mistakes. I also want to say this to kind of set the scene. I talked about this a lot in the ethics course, which you'll do much later in the degree, but the software that you will go on to build will have real world consequences. So, like if you deploy or you submit some code that's bad for your 1531 project, you might lose a few marks, you're like, that's not great for me, blah, blah, blah. If you go out and work for a company that makes software for airbags, this is an example that Kevin uses in the operating systems lectures. If you make airbags and you get that wrong, what happens? Yep, getting a few neck chops off here. People die, right? And like we can kind of joke about it, but it's genuinely serious. Investor demos, I had, this is more generally the fact that when you write software for companies and that goes wrong, you can lose the company a whole lot of money. That's bad for you because you lose your job. The company has to fire people, whatever the case may be. That comes down to lines of code that you have written on your computer. So I don't want to sort of over dramatize it, but the consequences of things going wrong are real, and we as software engineers are responsible for making sure that the code that people are using is correct. Cool. Okay, now have you already talked about this as well? I feel like I'm treading on the... Okay, cool, that's good. So, okay, there's this thing called risk, which is whether you break your wrist or whether you deploy some bad software. How do we deal with risk? Well, risk is usually due to the fact that there are errors in the code. And what we like to do is we like the errors to be as early as possible. So if you write some code and the code has a bug in it, when is the worst possible time for that bug to sort of be known by everyone? Yep. After release. If you've deployed your software and people are using it and they go, hey Nick, there's a bug in your code. That's not good. That's not what you want. By the way, now if you answer questions, feel free to come up and grab a piece of merch of your choosing. So you're welcome to come up and grab a piece of merch. What's the best time for you to have an error in your code? Yep.
While you're writing it?
When you're writing it.
When you're compiling, like pick it up then?
Yeah, when you're compiling it, even before you compile it, ideally, right? Because compiling takes like a few seconds. Really, you want, and as soon as you write the error, the code with the error in it, for something, maybe it's VS Code or your IDE to say, hey, there's something wrong with this code, you should fix it. So we call this shifting left. Just to give you some theory, there's 3 types of errors in programming. The first one is a compile error, which is like when you're writing C code, you forget a semicolon, and then you run gcc mycode.c, and then it's like, that doesn't work, mate, sorry. That's good, because you caught it early. You don't want to be missing the semicolon when the users are using it in production. That's bad. So the second type is runtime error. That's when your code throws an exception. Who here's had a seg fault, or a null pointer exception, or a null pointer error? Yeah, cool, that's a runtime error. The third error, and these are the nasty types of errors, these are logic errors. So your code ran, it return X success, return 0, happy days, but then it gave you the wrong answer. Who's had a logic error in their code before? Everyone, right? That's the bane of all programming, is logic errors. Now, one way you can fix logic errors is using jest tests, right? And Yuchao tells me you learnt that on Tuesday. You guys all know what jest tests are? Yep, cool. But But even writing jest tests and writing tests and running them, you know, that takes time. Ideally, we want to pick it up as soon as we make it or soon after. And this brings us to the idea of what if you could know your code was correct without having to run it. So when you do your jest test, right, you write the jest test and the test runs the code and it checks the output. Is the output yes, okay, happy days, if not fail. That's what we call dynamic verification. And you can probably figure it out based on the names of the lectures. Dynamic verification is when you run the code. Static verification is you don't even have to execute the code in order to verify it. And you might think, that's a bit weird. How do I know that it works without running it? I'll talk about that in a second. Making sure that things are statically verifiable is very hard, as you'll see. But to give you some examples, so jest tests is an example of dynamic verification. Another one is if you manually run your code and put in the input and test the output. That's what jest tests, just automate. Examples of static verification, when you run GCC, that'll do a bunch of checks, including type checking, which we're going to talk about. So your code doesn't even run, when you compile it. It's doing a static analysis on your code. This other one, just to give you a real-world example, is this thing called SAST, or Static Analysis Security Testing. It looks at your code. It doesn't run your code, but it looks at it and sees if there are vulnerabilities. And it goes, hey, I think that this code is vulnerable to an SQL injection or a cross-site scripting. You don't need to know what those are. But more broadly, it'll analyze your code for vulnerabilities and tell you when there's something wrong. Now, another one, apparently you guys haven't learnt this yet, but there's a thing called linting, which you're going to do very soon. That's another form of static analysis, where it'll look at your code and tell you, hey, you've got these style errors. Okay, so static verification. How do we statically verify our code? Now, it turns out that lots of people are very, very interested in this problem, because code has mathematical properties. Who here is good at maths? Everyone should put your hand up because you're doing computing degrees, so to some extent you're at least okay at maths. Some people are very good at maths and will understand this much better than me. I was good at English in high school, not maths, so I'm more interested in the concept of mathematical verification than actually doing it. But there are many people, many academics in particular, who think a lot about this stuff. And we talk about this concept of formal verification, where you can mathematically prove that your code is correct. We call it in philosophy a priori. You can prove it's correct without actually running it. Okay, software engineers, you guys are going to get the pleasure of doing a course called Seng 2011, which is reasoning about code. In that course, what you do is you use a programming language called Daphne, and you write the code in Daphne, and then run that code through a theorem prover, and that will verify the semantic correctness of your code. So it will actually do some sort of mathematical proof on your code, which is all automated. Another way you can do this is proving the code by hand. So I don't know if I might have stolen this from another slide you guys have already seen, but the Linux microkernel was verified by hand. I think it was about 20 years ago. They've probably changed it since. Yeah, shoot.
Do you mean the Linux microkernel?
Sorry,
Do you mean the Linux microkernel rather than the Linux kernel?
Maybe. If I got this wrong, then whoever wrote the slide before me got this wrong. That's my only excuse. It might be because it's a microkernel. It's called Minix, and Linux is the whole thing, like with the whole operating system.
They're two different things, but they're both Unix derivatives.
Okay.
Linux, it's not actually Unix, but it's the same kind of style of Unix, like rationality of everything is a file and so on.
Yep. Okay. Linux, Unix, I guess the broader point is they have a microkernel, which is an operating system, for those of you who don't know that. It took not actually 20 years, but one person's worth of 20 years. So if you had one person doing it, it would take them 20 years, but they had like a team of however many, 100. For 10,000 lines of C. Now 10,000 lines is not that much. I work in a repository that has maybe close to 1 million lines of code. So 10,000, not very much code. Takes 480,000 lines of proof. So you can prove code by hand, and the really cool thing about it is if you prove it by hand, it is bug-free. It is 100% completely bug-free. There will be no bugs, definitionally, categorically. Another way you can do it, because that is super expensive, is a mix of the two. So I've stolen this from the advanced operating systems course, and you don't have to worry about it, but the concept I'm trying to get across to you is that they've got this implementation in C, they've got an implementation in Haskell, they do some parsing, and then they use a proof language called Isabelle, which is very similar to Daphne, to prove mathematical properties of the code and turn them from different models into sort of different abstractions of models. So you've got the abstract model that goes into an executable model, executable goes to formalized C, and what it basically means is that by the time you get to this formalized C, the code is coherent to this general, more abstract model of what it's trying to achieve, and the code itself actually works. And SEL4 is an organization, SEL4 is an operating system produced by a group called Trustworthy Systems. They live over in K17. They're run by a couple of academics called Gernot Heiser and Kevin Epfelstein. If you do the operating systems or advanced operating systems course, they'll talk a lot about SEL4. Also, by the way, highly recommend doing those courses if you want to understand verification, software safety, and any of that kind of stuff. Really good courses. But more broadly, what they have is they've produced an operating system which is pretty much bug-free because they have formally verified it. Does that make sense to people? Cool. All right. Now the problem with that, I will tell you now, we don't formally verify our code at Atlassian because that is very time-consuming and expensive. Proving code correctness formally via mathematical models takes a long time, but what if we could find a way to say, here's our code, I'm not going to prove it by hand and take 10,000 years, but we still want to be able to do some form of static verification. And what we can do is we can use the fact that code has types. What's an example of a type? Yep.
Number, string, character.
Number, string, character, what else? Up there?
Like array, object.
Yep. Arrays, objects. Yep.
Boolean value.
Boolean, yep. True or false? Yep.
Floats, doubles.
Floats and doubles. Got the main ones. Yes. Undefined or null or what's the other one? Nan, not a number. So types are these things that you guys understand and exist in code. What we can do is we can look at the types because, and I can't remember exactly what it is, but types form essentially a mathematical model which is provably correct. I don't know if it's Turing complete. Do you know, Yuchao? The type system of a programming language is, they're Turing complete, is that it? I don't know. There's some special term for it, but basically means the types of a program have mathematical properties which you can prove stuff about. So if you show that the types of a program are correct and they are coherent, then you know that the code might be correct as a whole. So we call this type checking, and this is what we do in our code. And this is what TypeScript, which I'm getting to, is all about. So if type checking in your code passes, the code might work. But if it doesn't pass, then there's probably an error in it. That's all I have to say on the mathematics of type systems and formal verification. If you're interested in this, there's many courses at UNSW on it. 3161 is really good for understanding type systems. That's concepts of programming languages. There's another course called Informal Methods, which Carol Morgan, who's like the most educated person about formal verification ever, it's called like the lost art, and it's basically about how do you do sort of formal verification that's not formal. I haven't taken it personally, but my broad point is there's a lot of stuff ahead of you that you can go into in this space. All right. Type systems. Most programming languages, and most of the ones you work with, have this thing called a type system. Now you guys have just done a very good job of telling me what different types are. What types does C have? Yep. Int, float, double, character, chart, yep. No, not technically. You have arrays of strings. Now, it's kind of moot because everything in C is actually just a number if you think about it. JavaScript has a type system as well, and you've all been coding JavaScript already, right? Yeah, so you've been starting to work with some of those types. TypeScript is going to add some extra elements to this, which we'll talk about. Java has a type system, Python has a type system. Now, I want to make some terms very clear because people throw these around a lot and it's very confusing sometimes. So a statically typed language is where type checking is performed statically. And you as a programmer have to declare the types of variables using these things called annotations. And what I mean by that is, let's say I have a file. Actually, let's go here. Let's write some code. All right, touch hello.c. Oh, sure. The terminal or the? Oop. I've got a file called hello.c, and I'm going to say int main int number equals 5. This thing here is called a type annotation, where I have to explicitly declare number is an integer and main returns an integer. A dynamically typed language like JavaScript is an example. I don't have to say what any of these types are. That doesn't mean that the types don't exist. They exist at runtime. So they exist when you run the code. It knows that this is a string and this is an int and all that sort of stuff. But statically, there's nothing here telling me that. Does that make sense to people? Cool. All right. Now, another sort of point of nomenclature I guess I want to talk about is strong versus weak. This is generally, I won't talk about it much, but C has a very weak type system. Even though it's statically typed, it's very easy to sort of get around that fact, because you can do stuff like this. You can say int star bad pointer equals, I think you can do this, number, return 0.
It should be n. Is n without the pointer?
No, I want to cast this. That's why it's a bad pointer. I don't want to get the address of it. I want to actually say this is now just an int star. So if I go gcc hello.c, that will sit and wait. It's kind of like, oh, don't do that. That's a bad idea, because it knows that I'm trying to misbehave. But it won't actually, it'll still give me my a.out, and it will still compile. So that's just a warning. Yes?
I mean, technically that is undefined behavior with that though.
Yes, but you will get languages that will actually error and prevent you from going any further, which is what we'll talk about. Sorry, yes?
So what did you do that? Because I haven't seen it.
Oh, sure. So what I did is I declared a number, which was an integer, and then I did what's called a typecast, where I say, hey, I now want you to think of this as a pointer. The actual value is the exact same. Like, so if I do printf %d number bad pointer, I need to do this as well. Hash include stdio.h. And I run this, oh, sorry, GCC. Ah, thank you. See, static verification doesn't let me make mistakes. All right, warning, warning, blah, blah, blah. And then I can do a.out. It prints 5 and 5 because these are actually the same piece of data, but I am now treating this as a pointer. Don't worry about it too much, but strong and weak type systems, strong type systems will put more checks in to make sure that you don't do that kind of stuff, because that can lead to weird, as you said, undefined behavior. I haven't done COMP1531, but that I believe touches on, it's in a language called Rust, which is also very big on solving problems about static verification. So that is of course, talks about it more. Okay, coding. Yay! We got through all the dense theory. I hope that kind of made sense. So JavaScript is a dynamically typed language, which means it lets you do stuff like this. Now I think I actually have this here in Yuchad's code. Is it this one? I think it's this one. Yep. Can anyone spot the error here?
I want to say that string is the number, while the out string is a string. But in JavaScript, the dominant type is string, so it's gonna like convert the number into a string for an integer. Also,
yeah.
The repeat should be string instead of repeat in the for loop.
Yes, that's it. Does anyone else want to take the credit because they also figured it out? Yes? Oh, yep.
The hello in the file applies
Yeah, you got them the wrong way around. I do this all the time, actually. You got the hello and the 5 the wrong way around. So, okay, let's go node many string root.js. This lets me run the code. Now, Node is an interpreted language, so there's no compile step. You guys know what an interpreted language is, right? Yes. Okay. It basically means there's like compiling the code and running the code are done all together. So there's no compilation, but there's nothing being like, hey, this is bad behavior. You have mixed up these two, because it's not statically typed. Enter our savior, TypeScript. So TypeScript you can think of as a separate language to JavaScript. It's like TypeScript, TypeScript is like JavaScript's older sister who knows better and is like, don't do that, that's a bad idea, or older brother. Its job is to check the types in your program and spits out JavaScript. So what I'm going to do now is make a new file called lec.ts. So TypeScript files end with a .ts extension, and that did not work. Copy, paste. Oh god. Okay. There we go. So this looks a lot like regular JavaScript, but you see we've got these funny things here where it says colon number, b number, console.log sum12. These things are called type annotations, and when you write TypeScript, you have to put annotations on the types of variables so that you know what to look for. So if I go back to here, we're going to fix this code. So repeat should be a number, and str should be a string, and I'm going to change this to be rename.ts. Okay. Now, VS Code is very clever and has told us, hey, you're messing up here. This is what I said about picking up as early as possible. I don't even need to try to compile the code because VS Code is doing it for me. But let's say we don't have VS Code. Let's say we're using TextEdit. Do I have this? No, okay. If I go node modules.bin ts node many string root.ts, it's going to try to run that and then be like, not happy, argument of type string is not assignable to parameter of type number, because I got it the wrong way around. But if I do this and then run it again, hello, 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 hello. Make sense? Cool. That's TypeScript. If you understand that, you understand what TypeScript is, and hopefully from all that preamble why we use it. What's the error in the code below? I actually made this bug when I did 1531. Back in those days, the course was in Python, so we didn't have types. Sorry, we didn't have static verification. We did have types.
There's 6 parameters while there's 7 in the function call.
Yes.
Also, like, there should be 5 numbers instead of 3.
Yeah, exactly. So if I copy this, and this is a very common thing, I have made many errors just because of either mixing up param names or having functions with too many parameters. Let's get rid of this. So I paste this here. Expected 6 arguments but got 7. Okay, let's take out one argument, and then, okay, argument of type number is not assignable to parameter of type string. Okay, we'll make it a string now. TS node. Oh, this is the same file. Oops. You can see that now compiles with no problems. I've kind of skipped over the bit about how we run TypeScript, but this is just the high-level overview of now you've got these type annotations, and now they are enforced. So if you mess up, TypeScript will tell you. Okay, if you want to put TypeScript into your project, you run this command. I'm not going to do it because I already have it. What that will mean is there will be inside your node modules. Whoa, that's a lot of stuff. Let's look for it. ls node modules. Here we go, ts node. Now there's a library called ts node that lives inside the node modules. So what we're doing here is we're actually running a binary which will check ts node. Now this is kind of ugly, so what we're going to do is go to the package.json, and in our scripts, do you guys know how to do this?
Yep.
Cool. As in you learnt it in the previous lecture? Okay. I'm going to say ts node, and then what is it? Node modules, blah, 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 blah. Cool. And now I can go npm run ts node many string root.ts, and that will do its thing. That's cool. You can also include that. Don't worry about it though. Now, there's two ways you can run code with TypeScript, because what actually happens when we do this thing called ts node, there are two steps. The first step is we have to convert our TypeScript code into JavaScript, because I'll tell you a secret, TypeScript's not real. That's not actually true. TypeScript is real, but it's sort of like, it's like if you put clothes onto JavaScript. It's like, hear me out for a second. You know in the Bible, when Adam and Eve, they're like, you know, their whole thing is they're naked at the start of the story, and then they're like, oh no, we're super embarrassed, they put clothes on. TypeScript is like Adam and Eve with clothes on, and JavaScript is what happens when they're just, you know, they're regular human selves. So we have to do the process of converting TypeScript into JavaScript, and then running the JavaScript code. And we do that using the TypeScript compiler, or TSC. So I'm going to add a new command here that says TSC, and then I'm just going to do that. Yep, that should be fun. Oh, thank you. npm run tsc many string root.ts. So this is going to run the TypeScript compiler. It's going to do its thing. Now if I go here and make a mistake, let me just get rid of that. Like this, it's not going to like me. Now my code is going to fail to compile, and I haven't executed anything. It's just going to be like, hey, this isn't working. You have to fix this before you get any further. If it does work, just delete that. npm run tsc blah blah blah. You'll see it actually spits out a file called manystringroot.js. Now I didn't make this file. This file is auto-generated. So what happens is TypeScript makes sure all the types are correct and then takes the clothes off, so to speak, and it turns it into JavaScript. Then we can run the JavaScript with just our regular node manystring root.js. Like so. Make sense? Question?
Were you not using like Node.ts before or something to run TypeScript? Why would you not use that?
That's a good question. You probably always want to run it using ts node, but ts node, I'm just showing you what ts node does under the hood. So it runs tsc, TypeScript compiler, and then it runs node. So it just does those two things together. So you don't have to worry about any of what I just said. You can just say npm run ts node many string root.ts. Cool. All right, let's crack on because we have lots to talk about. So I talked about these things called type annotations. We typically add types to our programs by putting the type name after a colon. You'll notice that in C, that's also got type annotations, but it's just slightly different. Like, right, there's no colons here. We just say int number equals 5. If I was to convert this code into JavaScript, or sorry, into TypeScript, I'll call this hello.ts, and let's comment that out. I'd have something like function main number. And this is going to return a number. It's going to return 0. And then I'll say const number. Oh, this is bad because number is a reserved keyword. Let's call it number equals 5. Now, you can do whatever you want with that. So these annotations make sure that when we call main, we can't do something like this. Const hello string equals main. It's going to be like, don't do that. That's silly. Number is not assignable to type string. You buffoon. Similarly, I can't do this. I can't say number is a number and then give it an actual type of string. So it's doing all these lovely checks for us. Now, if I do this, if I say const name equals uchow, why doesn't it like that? Oh, it's just being annoying. Okay.
You didn't without the types.
No, that's okay. It sometimes just gets annoyed at me. I don't need to declare the type here because TypeScript can kind of figure it out. Sometimes TypeScript will need you to tell it what the types are, and that is actually configurable depending on what TypeScript settings you have. All right. Basic makes sense. Is anyone like, I still don't quite get what this whole TypeScript thing is about? If you do, that's okay. I can go through it again. No? Okay, cool. Let's get into some more syntax. So, we talked about this with functions. Parameters have a type. Return types have an annotation as well. Next thing is a thing called a union. Now, do I have this code? I do. That's lovely. Oh, but this code has a bug in it. I'm going to fix that bug. Okay. So I'm going to say npm run ts node example unions.ts. And that's going to sit there and it prints ready, ready, ready. Now, which ones were ready? Let's find out. We'll do this. Use our lovely tilde, not tilde, backtick. Okay, so 1, 2, and true were allowed. Don't worry about what the code does so much as this part here. What do you think this code says?
Ready has to be either Boolean or not.
Put your hand up, please. What does someone else think ready says? Okay. If you give me a Boolean or you give me a number, that's okay. If you give me anything else, if you try to do this, game over. Not happening. So a union is just like a set union where you can have this or this or this. So I could actually say Boolean or number or string, and then that would be okay. It would be fine. If I take this away, it's going to complain, right? Because Booleans work, but numbers don't. Make sense? Pretty straightforward? Yeah? Cool. I'm just going to smash through these because you can play around with this as you do it. The next one is arrays and collections. Here we go. Arrays and lists are the same thing. In JavaScript, arrays will be like this. Const array equals that. And then you can just put whatever you want in it. But now, we have typed our arrays. And we have this interesting thing here where we have this weird syntax with the angle brackets and it looks kind of funny. That's called a generic, and you don't have to worry about that because there's lots more in later courses coming on that topic. But what this says is, hey, I can take in a string or a number, and then that array can store a string or a number. That's pretty cool. What if I tried to do this? Console.log, create 10 list, hello. And then I go npm run ts node, example lists. That all works fine. If I now try to do true, TypeScript compiler is going to stop me and say, hey, you can't do that because this is not one of those allowed types. Yes?
Why would we need TypeScript? Like, you're pretty much just learning a new language and then going back to JavaScript, right?
The computer's making it go back to JavaScript.
Yeah. So, like, if we can just type correctly in JavaScript, isn't that enough?
Yes. But who here can type correctly in JavaScript? Because I can't.
Okay. So it's just like, just pick up on your errors, do proper testing, and you don't need TypeScript.
I guess this is my point at the beginning of the lecture where it's like, well, you could write really good jest tests, but that takes time. The jest tests, like when in software engineering, time is money, and so if I could avoid writing 10 jest tests by running the TypeScript compiler once, I will save so much time and therefore money. Does that make sense? It's a good point though, because you're like, well, now I just have to do all this extra stuff and it doesn't make any difference. In the long run, you are saving time because what you're doing is you're moving the error to here when I'm writing the code as opposed to when I'm writing the test, as opposed to when I'm trying to deploy it, as opposed to when the customers are using it. We're shifting left. Yes?
I think also another issue is lots of different programming languages have very strange rules about type conversion for many different things.
For sure.
So JavaScript is one of them. So like, no matter how much effort you make, you will always end up in situations where you will accidentally miss something because it's really hard to figure out what coercions are going on. No,
100%. Sorry, I'm just gonna flick back here because where did we talk about it? Yeah. So type checking is not like a silver bullet. It's not like hand verifying your code by hand. But if the type checking passes, you have a level of what's called assurance. You're like, well, I know that it might be correct, or it's closer to being correct than it was if I didn't run the type checking. This is a really good question, by the way, because I can understand it can seem sort of peripheral, especially when, you know, as I remember as a student, it's just like, I just want to write code and get it out there as fast as possible. When we do software engineering as a practice, we have to go slower, because if we don't, we will make mistakes and then airbags will stop working. Yuchao.
Yeah. So in real life, it's really hard to make all of our software project with no error. So we do as much as we could to check tabs and make sure that there are less errors. And TypeScript is kind of a static verification, means that we do not need to run the code. And then we can potentially figure out some errors that is in our code. Yeah.
Yep, shifting left, moving everything early. There was something else I wanted to say about that, but that's okay. What we can also do is like a type def in C. We can say type my fake type equals string or number, and then I can just move that here and do that and say my fake type. That's pretty nice. And I can also take this out and say my fake type. I run TS node, and that does its thing. Oh, that doesn't like me because I still tried to do true. Happy days. You can also use some syntax here, which is a bit less. This is like Java kind of generic syntax, but you can also say my fake type and then double brackets, which is more C-like. And that'll do its thing. All right, that's aliases. Optionals. Optionals are very useful because sometimes when you write functions, you are going to want to sometimes have a parameter and sometimes not. So what this function does, let's say I have a name like Yuchao, and I want to get from character 0 to character 2. So I get the first, the first the first 2 items in that string. So it'll be 0, 1, and then they'll finish at 2. So everything from 0 up to 2, not inclusive. If I just want to get everything in the string, I don't really care about, I can start at a certain place, but I don't care when it ends, it'll just end at the finish. I'm going to say end is an optional parameter to the function, which means that if I don't include it when I call the function, TypeScript's not going to yell at me. So if I take this question mark out, and then it's going to be like, what do you mean? Where's the third argument? Come back. If I put this in, it's happy. These are really useful because then sometimes you can have certain use cases where you give it the argument and certain ones where you don't. Yes? No, you can have more. But because they all go at the end. So if I try to do this, it'll go, a required parameter cannot follow an optional parameter. So you have to have all your optional parameters at the end. Otherwise, for the person calling the function, it doesn't work, right? Because you're like, like you said, which one's optional and which one's required. Yep.
On C, like you can like declare the values with like initial value, right? Like the optional one. In this one, like you have to use an extra line to like declare modified. Like, do you have to do that, or like can we just declare the like the optional value in the function like parameters?
I think I understand your question to mean this will be why isn't it doing that? Basically, the type of this value is number or undefined. So this is equivalent to saying number or undefined. Does that make sense?
No, like in like C++, like when you're inputting like the parameters, like you can just like declare int a and like bool b equals like 10.
Yep.
And like, is there an equivalent for that? Like, instead of like you checking whether the like variable exists in a separate line. Like, can we eliminate like line 9 somehow?
Oh, like if end is undefined kind of thing.
No, like inside the like parameter line.
Yeah. I don't think so, is the answer to your question. So I'm not fully understanding what you're asking, but I think the answer is no. There's this cool thing you can also do. This is saying end or string.length. So if end is undefined, or will take it as being false. Or if it's null, if it's null or it's undefined, it'll be false. Or if it's false, it'll be false. But in this case, it'll be a number. But we can also say question mark string.length, and what that will do is it'll say if it's undefined and nothing else, then we default to this case. So this is really useful because sometimes if I want to do something like const random number equals end, this is, I don't know what, your TypeScript settings seem to be a bit strange, Yuchao, sorry. If I TS node this.
So there's an equal online.
Oh, sure.
Sorry, 1 second.
I don't know what your TypeScript settings.
Okay.
Okay. Thank you. That seems to run okay. Okay, TypeScript has I think you've got non-strict settings on. Don't worry about that. TLDR, that's optional, so super useful. Yes? Yep.
If you input 3 arguments and the third one's a number, does it store it in end in this case? Does it prioritize the optional arguments to just store any optional ones that you input in the first of the ones that you've listed?
Yes, that's why all the optionals are at the end, because it will know, okay, if I gave 3, then you have these 3. If I gave 4, then you have these 4. If I gave 2, then you only have these 2.
What if you had 2 optionals of different types, and then you input the first 2 and then the optional of the second of the 2 optional types? Like if that was a string, and then you input the first 2 and then the string, then notice skip the number.
I don't know, let's have a look. Why does this work? Oh, I'm running the wrong thing, that's why. I thought the TypeScript compiler is doing a weird thing here. Oh, it's because I gave it 4, sorry. It should do this. Yeah, it doesn't like that, because it thinks it's going, hey, this should be a number, but you've given it a string. So you have to do it in the right order. Different programming languages will let you mess around with this differently. It's really just syntactic sugar. Sorry. Pardon?
In Python, like you can just write down the like parameter and equal sign the value.
Yeah. So there's lots of things. This is syntactic sugar, which I don't want to get too hung up on. Another one is objects. You guys have all done objects in JavaScript? Yeah. Yep, cool. So this duplicate identifier, oh, that's weird. Okay, interesting. I won't go through this too much, but basically you can have optional parameters and required parameters. So if I take away age here, it'll say, hey, cannot redeclare block scope variable. Why is that? Objects.js? No, that's weird. Okay. Something's going on with your TypeScript here, Yuchao. I don't know, some of your TypeScript settings are a bit strange in VS Code, but that's okay. If I go TS node, example objects, it'll say, hey, property age is missing in type because age is required. But if I make it optional, then I can do whatever I like. Or if I take it out and then I try to assign the age down here, it's also going to complain. I will leave this to you to play around with, because we could spend 10 hours litigating TypeScript syntax and what works and what doesn't. You could spend your whole career doing that. I guess what I want to try to impart on you is like, this is cool and I would spend time playing with it. But if you understand, like, sorry, what was your name, by the way? You asked the question, what was your name?
Me?
Yeah.
Jaden.
JD? Jaden. If you understand like the reasoning behind Jaden's question of like, why are we doing this, then that's kind of what's really important. Syntax is like, you can spend, you'll learn syntax in a week. If you understand static verification, you will not only master your degree, but be able to master software engineering in general, or at least one part of it. Okay, the last thing is this thing called any. This is like what you do when you don't want to do TypeScript. You say, hey, I'm just going to be, this could be anything. I really don't care. This is just whatever. And that means that I can say substring, point that, false, array with that and that. And it's like, sure. You said literally anything, so I don't care. And it, oh, that's weird. Oh, it's dictating my finger. I don't know how I did that one. It's like TypeScript is really working some wonders today. Okay. Oh, it's still doing it. What have I done, Yu Chow?
I have no idea.
Okay. It's like VS Code is listening to me.
VS Code thing.
Okay. I'm gonna kill this terminal and all right. There we go. My God, undefined behavior indeed. The last thing I want to talk about is give you a bit of a teaser for more to do with types. So we talked about verification, we talked about type systems. Types actually exist in a big hierarchy, and any lives at the top. It's the mother of all types, the super type. It says, hey, everything can be an any. We all are welcome here. So strings, numbers, booleans, any custom object or types that you make. Any has a sort of dark younger sister called never. And never is what we call the bottom type. You don't have to understand that. But I just wanted to impress upon you that these types aren't just sort of floating around in a big pool. They live in a hierarchy, and when it comes to building your own types, you're going to end up building them in this hierarchy. There's much more on this in COMP1531 when you get to object-oriented programming, inheritance, and polymorphism. That all exists within this idea of type systems and type hierarchies. And there's even more on it on COMP3161, which is the Concepts of Programming Languages course. Okay, almost at the end of this part. I just want to talk briefly about static verification in industry. So again, to your point of like, why do we do this? At Atlassian and most places, we use at least some form of static verification to, again, essentially save costs, because it's much cheaper to run the TypeScript compiler and check that the code is type correct than it is to see that the code is wrong when you're writing jest tests or when you're in production. And the idea is that every single piece of code that is merged into master or to main actually runs through type checking automatically. And we're going to see how we do that in the next lecture. As you have probably figured out, just because your code passes the type checker doesn't mean it's correct. So you still have to write your jest tests, you still have to do manual testing or whatever other form of quality assurance you want. And more risky projects will have more layers of verification. So for example, I do some work for a startup where we don't write any tests because I don't like writing. No, it's not because I don't like writing tests. It's because we just don't have time for it. We're just going to write the code, it passes the TypeScript compiler, that's good enough. And we do some manual testing. So the more risk there is, the more layers of verification you want, because you want to catch the bugs early. As I said before, this is a very broad topic with lots of interconnected topics. What I've done here is made a little mind map. It's kind of hard to read on the lecture on the screen. The green stuff is what we talked about today. The pink stuff is what is covered in other courses. The dynamic verification is what you covered in another lecture. And then the yellow is sort of not covered in a course, but you can go and look at it. There's so many places you can go to with this. It's TypeScript project configuration. Like, we didn't really even touch on the fact that there's this thing here called tsconfig.json, and you can play around with that. There's so much you can do with TypeScript in terms of, it's a very rich type system. You could do all these cool things with types. They're their own sort of separate language, independent of the actual code that you are writing. There's so much to this. So I couldn't do it justice in an hour, but thank you very much. We're going to have a break, and then we're going to come back and talk about continuous integration. Thanks.
And if you have any questions about working in industry or working in Atlassian, I'm sure like Nick will be very happy to answer. So
For sure.
you can make good use of the time during the break.
npm install JavaScript. try running? You got to add it to the script like we did with lecture. Sorry, I'm gonna run away from it. Because you can help with this as well. We're back.
No, he was. Yeah, he used to do it.
Because the package is initiated by IBM. So if you want to participate within the package, and also for the
specifically waiting for the
so we can't just use more to build the TS or the TapScript. But TapScript is installed using VM. So as Nick just mentioned, TapScript is a module installed so NPM doesn't need to be compelling and also
I feel like the guys spoke to pages with people.
yes,
And then you're waiting to sort of find details, like he was like showing you what cool stuff. No, I mean like the proofs of like theorems and stuff. It's not really bad. No, so like so the chat, you only need to know like what
yeah, so for JavaScript, there's no step that we need to do to compile.
you just do it.
This is what happens depending
Whoa, that must be like you want Wait, we should just ask them. Very good.
Yeah, I know it can be a little bit confusing at the beginning, but we can just
At the end, we got to ask. Wait, did you?
I asked the question. I didn't answer anything.
Yeah, if you ask a question, you can also take it. Yeah. No, that's okay. I did a thing called COMP with UNSW, and they like send you to a bunch of companies. So I worked at Tech. I worked at Lecture2. Yeah, so like they sent you to the company for 6 months at a time. So I worked there for 6 months, and then they're like, "Oh, you have a grant."
the slide, it should be where's this is the one. So you need to npm install, and then so this is the command line that we need to use to install the TypeScript packages, and then you will have all the node modules installed. You already installed using the command line.
So I can show you a few places, of course.
I did 1.1 as part of
Yeah, so it should be TypeScript and
so
then
it meant I
TS
could go straight and do 1.3.
Yeah.
So I extend like you.
And also we normally use dash save now. The reason is because we do not want to use
I did the
this
older
to
version of 1.1 1917
users
and it felt
but
like
it's only for
it doesn't, I don't think they do it anymore, but
So
it's
that's
a case
why
of
we
like
added dash
this,
save.
like you did the course that give able to use the credit as natural.
Yeah,
It's like doing
Yeah. So TypeScript does like syntax checking.
I work on a service called Postdoc.
So what if,
Basically, it's like
you
all
have
the emails and
all your
notifications. So I should have said
checking the output.
yeah, all the emails and notifications is managed by our team. So I basically spend my whole day writing TypeScript to make
So
emails.
you still need to submit.
Yeah, so TypeScript only.
Yes, well, they have a bunch of products that send emails and notifications to customers.
Yeah, it's just
And also internally as well. And so, yeah, we maintain a system that is
And it just works in this Okay, so we still need to do like all of our functions need to be manually generated.
yeah, internally. So,
Yeah.
I'll probably come back and so this is like here are all the things about these products that you use all as well.
So just
And
testing
at some point, we integrated this platform so that we send all the emails to Jira and all the emails to Confluence. So, anytime you get an email from either of
The
those,
project,
Yeah.
if we don't have any TypeScript code, is that going to reduce marks?
in integration spec.
Great.
so we mainly, I work with TypeScript mainly, which is why we chat like they do a lot of Java, so that's like implemented COMP1531, lots of Java. Kotlin is also used, yeah, the main ones. But there's a bit of Rust, like stuff that needs to be super fast as well. There's also Rust.
Like like I said,
You get some people who do, particularly people who work on, not so much on the lab system, you go work on embedded systems, you'll work with the same level, but where it's more high level work. I got an internship through like a co-op program, so they sent me there as part of the and then part of the internship is where it's like, oh, you want to graduate through the application process, but it is, yeah, so no, because it's all remote, so it's like you can do, they can just work from home. But they do fly people in, so we are having what's called like an on-site in January where they're going to fly people into America to come be here, like we have development desks and stuff. So if you, like I have one person in my team lives in New Zealand, and so she'll fly over for like the investment.
The direction of the company has changed because of
Oh, Scott. I'd say the direction of companies change because the direction of all companies change all the time. I wouldn't say because I don't think that like. Sorry, no.
like if you do like this and dynamic like verifications, there must be like some kind of balance like which has to
Yeah.
in such cases like how do you
Good question. Often, like people say, like I'll pick code. Okay, there's this bug in the code, so maybe a customer detected it, or usually like we've picked it up at some later stage. And you can't just fix it. And the idea is that if you've done your type check, your jet test, if you've done all those checks, and we're going to talk about that in a second, then the number of those errors are small enough not to matter too much. So it's like, yes, there will still be problems, but you probably can just fix them. Oh, that's great. I would say, like, broadly speaking, the culture of the company is very, like, I said to them, hey, I'm going to come and give a lecture to, like, talk about my YouTube about platform. That's so cool, that's cool. Some companies that I have worked at have been like, you should be working, why do you think you should? Blah, blah, blah. So, they are very open and understanding, and they're very big on, like, treating their employees well. So I go there, like, every day at the office, which, it's just like a technical thing, but I really like it.
one that could like
Yeah.
Menu or just like different each
Yeah, it's like the breakfast is the same every day, but then it's like a different lunch every.
Have you tried to reinstall
How many people like we get work with
Sorry, we don't have enough time for the break. Sorry about that. We need to go back to the lecture. All right. Okay. Back to
Thank you to everyone who I just chatted to. Talking about static verification and mathematically proving your code is very tiring, so it was nice to have like a short break. And thank you to you, Chow, who fielded everyone's coding requests because my brain was just fried then. All right, let's go to the next one, which is related. And we're going to hopefully do some more practical coding in this one. Continuous integration. Okay. I'm going to do a little bit of waffle at the start and then get into the coding and then do more waffle at the end. Hopefully that works a bit better than lots of waffle up front. I just very want to briefly say that it's so like, how to describe this? You guys are at the beginning, and so it's really hard to understand. When we say software engineering, you'll probably have a picture of like writing your TypeScript and doing your 1531 project and doing all this stuff. And it's like, yes, that's software engineering, but then there's all this other stuff. A very, very brief history of the course. This course was made in 2016, and the lecturer who they put in charge of the course was also the lecturer for COMP1531, which is about object-oriented programming in Java. And so what they thought what I'm gonna do is I'm gonna make this course just the same as that course, like copy paste everything, except we do it in Python instead of in Java. You think that's okay? And that is kind of software engineering, but maybe that's not all of software engineering. Then they gave it to the next lecturer. The next lecturer was a functional programmer who really liked Haskell. So what he did is he took the course and he kind of turned it into like Python, but sort of with Haskell-y things like property-based testing and all this other stuff. And that's also software engineering, but maybe it's not all of software engineering. Then the course was run by a web developer, and this is kind of the course in its current state. And because like that's what web developers do is they build web apps, so the course was about Express and TypeScript and all this stuff that you do in modern web development. And Yushao has a very fun job of trying to go, well, yes, it is all of these things, but then it's also something else, and maybe it's more academic and theoretical. And continuous integration is kind of like, it's really this philosophical question of, what is software engineering? And it's different things to different people. Same thing with continuous integration, where a lot of you, for a while, are going to be like, oh, continuous integration, pipelines. And we're going to talk about pipelines today. But it's not just pipelines. It's about, yes, the tools, which is the pipelines. It's about testing. It's about a process. So it's about you and me and how we write our code together and working as a team. And it's about all of these things. And so I don't know exactly what point I wanted to make with this, but just generally, these things are very abstract concepts, and you guys are at the start where you get to sow the seeds, and then over the years, because like as I said, I literally spend my whole day dealing with continuous integration pipelines and writing TypeScript. Your understanding of what this thing is will evolve. And I'm going to try and give you the best theory that I can up front. But I guess what I'm trying to say is it's not just pipelines. So continuous integration is the practice of automating the integration of code changes from multiple contributors into a single software project. TLDR, merging your changes into one place and making sure that they work. It's a primary DevOps best practice. We'll talk about DevOps later. It allows software engineers to frequently merge code changes into a central repository where builds and tests then run. There's lots of automated tooling, and it's all very fast. Okay, what we're going to do now is we're going to build ourselves a CI pipeline using our TypeScript project that we just made. So I'm going to go back to the lecture code, if I can find it. Here we go. And now this is actually, oh no, I'm in the wrong thing. Is it public? Yep. Code 24T3.
Yeah.
T.
It's 1531 before code.
Oh, public. Hang on. Sorry. code. Here we go.
1.31 and then
24 T3 CD. Oh, that was 3.3. Okay, cool. So I have all my. That's interesting. I have all my code that we wrote in the last lecture. I also have this GitLab CI type.yaml. I don't know what that is. That's weird. I'm going to make a file called GitLab CI. Oh, is it .GitLab CI? Sorry, I forget. I think it is. I've done this 1,000 times, but I still can't remember what it is. All right, and I'm going to copy this stuff in. Now, don't worry about what this code says for now. We'll make it work in a second. I don't know why the copy feature is not working on this computer. All right. I'm going to go git status. Blah, 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 blah. This looks good. Git add dot git commit dash m lecture code from TypeScript. Oh, actually, what I'm going to do is, yeah, don't worry about it. I'm going to go git push. Oh no, it's asking for your SSH key.
oh, yeah.
Thank you. Cool. All right. Now there's this lecture that Yuchao very kindly has made for me called Nick Lecture, and do we know where it is?
Yep. Safari.
Oh, yeah, here it is. Thank
Yep.
you. It's a Git repo, and it has this thing here now, which has a big red cross. Let's have a look at that. Unable to create pipeline. Find count character.
Or it needs to be within 1.31 folder to be able to use the pipeline.
Oh, okay.
Sorry, yeah.
That's right. So I just, like a folder called 1531? Like this?
No, not here.
Oh.
So it needs to be.
Oh,
So
I see.
pipeline
It's in
is
the
a service
Yeah.
provided by GitLab, and our school, like CSE, pays for this service. So this is an actual service. So if you want to practice this or work along next lecture, you need to have a repo under the 1531 project on GitLab. So if you create a personal project on GitLab, unfortunately it won't work because you need to pay for the service. But if it's a lab or it's a major project, like you can use the pipeline because it's paid for by the school. Yeah.
Can I just
So
check
if you follow the lecture and you can, why it doesn't work, it's because it's not under the 1531 folder. Yeah, but you can practice it for your lab.
This used to be my job, was just dealing with GitLab, and now it's all coming back to me. Okay. That should now work. I'm gonna found character. I think I also have gotten the syntax wrong. Found character that cannot start any token. Maybe I think I've just got a copy error. Oh, let's get rid of it. Let's get rid of this, and let's get rid of this as well. Stages. Checks. Okay, that looks fine. Sanity stage check script echo hello. Line 7. What's going on? Tabs are not allowed. Oh, I see. That's annoying.
Yeah, so in the last lecture, we Hayden talked about YAML file. They mentioned that the index matters in YAML file, so that's why it was broken. So
Yep.
if you find some, like this kind of weird issue, maybe it's because the index.
All right, commit changes. That's extremely annoying, but that's okay. Checking pipeline status. So what this is actually doing is running the pipeline now. We go back here, it gives me a lovely green tick. Okay, so this is a thing called pipeline. Now, has anyone had a pipeline on their repo before, or has anyone used a pipeline before?
They may have used that, but they don't know they have used that.
Yeah.
So for your lab marking, it's run by the pipeline. So all your lab marking is done by the pipeline. Yeah, but they may not realize it's a pipeline.
There you go. It's not a pipeline in the way that we're talking about it today. So, okay, what is a pipeline? Well, if I click on this, it'll take me to this lovely page called Pipelines in GitLab, where it ran this thing called Sanity. If I click on that, it'll show me this interesting output, blah, 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 blah. Oh, echo hello, prints out hello, job succeeded, happy days. What's actually happening here? All right, let's talk about it. I kind of want to draw stuff. That's all right. This is where I like having only in-person lectures, because then I can just draw stuff on the board. Let's talk about paint.io. Sorry, I haven't prepped this part. Paint online. Here we go. This is what I was looking for. All right. So when you write code, you write it on your lovely computer. There you go. That's your computer. Do. And then you push it to GitLab, and then it lives on the GitLab server. That's what you did when you studied Git, right? Git push, and then your friend over here can do git pull, and then they get your code and they're like, Nick, your code is broken, please fix it. What if you could push to GitLab and it tells you that your code is broken because it will run the tests automatically for you? So what happens when we run a pipeline is it'll take your code, and it has this thing called a runner. Can I write text? Oh, I can, that's cool. No? Runner? I want text. No, okay. This thing's called a runner. Sorry, I'm figuring this one out on the fly. Yep, cool. That thing's called a runner. Runs up and down. Yes?
I think you have to draw a text box.
I could draw the text box.
Yes, if you press the A and then just like select the text box.
It's like a rectangle, just print it with like text box.
Oh, that's funny. Okay, runner. Thank you. Okay. Sorry, I normally would put this on a whiteboard. This is a thing called a runner. So what happens is your code is transported over to the runner. And when your friend pushes their code, that code will also get put on the runner. And the runner's job is to run the code. In this case, what it's doing is it's just going echo hello and then finish. That's not very useful, is it? We want it to actually do things like run the tests, run the type checking, run the linting, which you haven't learnt yet. So let's make it do that. I'm going to go back here, and I'm going to change my, whoop, that's not good. I'm going to change my GitLab ci.yaml file. So this is the YAML syntax, which you guys learnt recently apparently. And I'm going to change this to say, okay, I'm going to have, let's say 2 stages. One is going to be for static verification, and one is going to be dynamic verification. And what's going to happen is it's going to go, we'll call this static verific, nope, this is called build type check. And the script is going to be npm run tsc. And that's going to run the TypeScript compiler, like we learned about just now, and check whether the code is statically correct. Then I'm going to have another one that's called test, and this is going to be from stage dynamic verification, and script is going to be npm run test. And now what I'm also going to do is get rid of all the tabs from here. All right, that's better. So I'm going to git add .gitlab ci.yaml, gitlab, here we go, git commit, update CI file, and then I'm just going to force push. Oh, sorry, you Jeff. I'm going to force push just so I overwrote that previous commit. Oh no, it doesn't like that. Hang on. Let me fix this. Permissions. Where's force push? I don't think you have the power to do this, by the way, but I'm just. cheating here.
Force push to main.
Oh no, it's on branches. Repository, protected branches, allow force push. There we go. Don't ever do this.
You won't be able to do this because your main branch is protected.
Sorry, could you enter your
Oh,
again?
sorry.
Yay! Okay, now hopefully that will work. Let's go back to Nick lecture. Now you can see the pipeline is running. That means it's still going, it's doing the type checking. This is what we call pending. Yeah, the pipeline is created, and we're waiting for the first step to finish before we move to the next step. So what you can do is make steps reliant on each other, or you can make things run in parallel, depending on, well, I need to build my code first before I can actually run the tests. Now in this case, the type check failed, probably because we've got some bad code in there. Node modules bin TSC not found. What do you think I've done here? Yep.
I think you set up your like TSC on your local device so that like it's not gonna have the node modules.
It's not going to have the node modules. So you guys have done package management stuff, you've done NPM and all that? Yep. So what's happened is that I've done all the coding on my computer and I'm like, yep, this looks good, tick. However, on the runner, it's what we call a clean environment. And this is really useful because if you test everything on the runner, then you know it doesn't just work on your computer. When I was teaching, I would have students come to me and go, but sir, it works on my computer, why did I fail the auto test? And I was like, well, it didn't work in the CI, or it didn't work on the standardized environment. So that's why this fails. In this case, what we have done is we have installed the node modules locally, but we haven't installed them on the CI, right? Because we didn't tell it to. We didn't do our npm run install. So what I'm going to do now is say npm run install. Or I think or maybe it's just npm install. Check that's correct. Yeah. So let's do that again. Git add, git commit, install node modules, and git push. Oh, and sorry, you got your key set up. Who thinks that this is going to work? And it's going to give me a nice big green tick. I love your confidence. That's the confidence that we all need. Who thinks it's going to fail? Yes, why?
Because you don't npm install on the second thing.
Oh, I like your thinking.
Also, it feels just bad to download everything every single time.
It feels bad to what, sorry?
Download like the package every single time.
Like to do the npm install?
Yeah.
Yeah, for sure. That means it takes a while. But it means that you know that from a fresh clone, this code works. It's not just because of some weird configuration that you have on your laptop. My friend up the back who's just about to head off gets a free pair of socks because he answered a great question. You want to question now or yeah? Sorry, I was going to give this to you at the end.
Sorry, I need to go somewhere as well.
Okay. Should have called. Oh, that was 2 pairs. Sorry.
I can get one.
The second pair is reserved to another question that I really like at the end. Okay, type check failed. Let's have a look. Now, why did this fail? This failed because our code is not type safe. Probably because of some examples that we've messed up here. Duplicate identifier, blah blah blah. I'm just going to cheat and get rid of all the code. That's a good way to solve our problems. Star.js, star.c. Have we got it written? a.out. Cool. I'm going to make a new file called hello.ts. And that's just going to const string equals uchow is the best. Console.log string. All right. Does that work? npm run tsc. Often when you experience a code failure in the CI, the first thing you do is say, can I reproduce this locally? run the code locally. If that doesn't work, then there's probably some configuration issue that you've messed up. Somehow your environment is different to the pipeline. In this case, we fixed it, so it's all good. And I'm going to go git status. Whoa, that's a lot of changes. That's okay. Git add dot git commit. Remove files. And git push. Oh, sorry.
All good.
All right. Pipeline's running. Who thinks it's going to pass? Who thinks it's going to fail? You think it's going to fail now? You think it's going to fail? Let's see. It's still going. Some more things about pipelines. When the assignment or the project is due, you remember how I said there were 2 computers? What if there are 800 computers and they're all pushing to this one poor runner? What do you think happens?
They download the node modules every single time.
They download the node modules every single time. Yes, that's okay. What do you think happens to this computer? Up the back.
More computers need to get allocated to...
More computers need to get allocated. I think that's actually how they do it these days. Back when I ran the courses, there was 1 computer, and so we'd have not only COMP1531, but all of COMP2511 as well. So you'd have 1,000 or 1,500 students all pushing their code at the same time. Yes? The runner's going to crash. That did happen a lot. Yu-Chao can attest to that. The runner crashing when like right before the assignment's due. Luckily, I think they've improved that. But it also means that maybe the runner doesn't crash. It means it's just a bit slow. Yes?
I think there should be like some kind of bottleneck issue.
Yeah, exactly. There's a bottleneck. Because what happens is the runner can only process a certain number of pipelines at the same time. So what you'll see is a thing that says pending. And it looks kind of yellow. I don't have an example for it here, but it's kind of yellow and it'll say pipeline pending. I was going to put a screenshot in the lecture slides because I thought it'd be funny of students being like, oh, the pipeline's not working. The pipeline doesn't do anything that you can't already do, right? Because we've just like looked at the code. We've just written this code. All this does is npm install, npm run TSE, npm run test. You can do that locally. Yu-Chao will probably say more on this, but if you can't get the pipeline to work, and it's definitely not because your code is broken, some configuration issue, or it's 2 minutes before the assignment is due and everyone's pushing, you can just run all this locally. The pipeline is more about the process of software engineering than like actually stopping you from getting your changes in. Now, okay, this failed. Why? It failed because npm run tests, okay, it runs jest, no tests found. Because we didn't run any tests. How does the pipeline know whether it failed? Like, it didn't throw any errors. How does the pipeline know that it didn't work? Yeah.
Is it because of the exit code?
It's the exit code. Who knows what an exit code is? A couple of people? Hopefully you should all know what an exit code is. You know in our C program when we said return 0? That's exit success. That means the program passed. If we return 1, that means the program failed. So what happens in the pipeline is it runs all this stuff. And if it returns 0, then it goes green tick, pipeline succeeded. Like your program could print 5 million warnings, but never actually return 1. It returns 0. And so it's like, well, the pipeline passed. In this case, we didn't run any tests, and so Jest said, hey, probably something's wrong here, so I'm going to return 1. Pipeline goes, oh, 1, that means there was an error, so I'm going to fail the pipeline. We can solve that very easily by making ourselves a test. I'm going to call this hello.test.ts, and then just say test hello. I'm going to expect true dot to be true. I think this will pass most of the time, if not all. Git commit, tests, git push. Oh, sorry, Yu-Chao. Now, to your point of the node modules were only installed on the first step. They're only installed here. And so that means this step will fail. Who agrees with, what was your name, sorry?
Jamie.
Who agrees with Jamie? Who thinks this step is going to fail because the node modules aren't installed on the second step? I would agree with Jamie. I think it's a pretty fair point. Let's have a look. Okay, pipeline's still running. NPM install does take a while. Oh, this passed though. Let's have a look. Running. Oh, job succeeded. Hell yeah. That's great. But your point is still correct. Can anyone tell me, just by looking at the code, what might be the reason that even though we didn't run npm install here, it seems to work? Someone that's not you two. Just by looking at the configuration. You don't really have to understand it, just see if you can detect something. Yeah.
Because the static verifications run first and the machine doesn't get wiped, which the status.
You are correct that the static verification gets run first, but these are actually two separate jobs. So if you look at this, it'll say running on instance blah 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 blah, preparing Kubernetes, preparing environment. This is actually a whole different running environment to this one, right? It's got its own environment. I don't know if that's it's easy to see necessarily, but you can understand that these are two different instances of the running. When doing software engineering and you don't know something, it's always good to just sit for a couple of minutes and just look at the code. That's one of my favorite things to do, is just sit down, I look at the code, and then I think, oh, what's this? What could that be? This thing called cache. Now I'm not going to explain what a cache is, because it'll take too long, but what this essentially means is that because, like you said, static verification is run first, we run npm install, and this setting says, hey, because I don't want to install the node modules for both static and dynamic verification, I'm going to do this thing called caching them. And caching is like when you save it for later. You know, if you like get a snack or something and you're like, I'm going to save this for later, and you like, keep it in your bag or you keep it in the fridge, that's like a cache. So I'm going to save the node modules for later, so that in dynamic verification, that folder is still there. So they're two different running environments, but some magic that even I don't fully understand will essentially mean that you can persist this folder and use it the second time around. Cool. Any questions? You think, all right, that's cool. Yes?
But it's not stored in the cache because you run the static verification first?
Yes.
Yeah, so if you run the dynamic or the static, it will work.
Spot on. Yep.
This is a very general question.
Sure.
What's the advantage of using pipelines as opposed to just like testing locally on the machine?
It's a very good question. That can be, you can get the second pair of socks. Oh, hell yeah. Good catch. All right. We're going to talk about, well, okay, there's these lovely pipelines, but Nick said that you can just run it on your computer anyway, so why would you push it to this whole separate environment? Great question. Let's go back to the lecture slides. So continuous integration is this process. It's the pipelines as part of it, as we talked about, but what it's really about is, okay, you write your code, you git commit, you git push, you build it, you test it, right, code works, bang, merge it in straight away. And do that again and again and again. I think when I finish this lecture, I've got to go back to work, and I've got 3 different pull requests, which you guys call merge requests in GitLab, from what I understand. I've got 3 merge requests sitting in review, and they've got CI pipelines that are waiting. And they're all just little code changes, little hit merge, go straight to master, and then it's on our way, do the next ticket. And that's how we do software engineering, is these incremental pieces, and we do this thing where we continuously integrate those changes into the overall code base. So I'm going to talk more about that now. I mentioned this thing earlier called DevOps. Don't worry too much about what DevOps is, but I'm just giving you some high-level background. I was talking to a friend who I also met teaching COMP1531. I was talking to them recently, and they work at this tech company, which I'm not going to name, but they do software development where the engineers write the code, and then what they do is they say, can the QA please go and take this code and test it? They don't write their own tests. You think, what? People don't write their own tests? Oh, scandalous. The reason for that is that it is much cheaper for this particular company to have engineers write code and then make the QAs manually test it, even though manual tests take much longer because these QAs are overseas and they're not paid very much. So this is not ethical, and you should not do it if you ever run a tech company. But that's just what they do. And honestly, this was how software engineering used to work, where you software engineer write the code, right, okay, all right, code's done. Can you go and test it? Test. Hey Nick, your code's got bugs in it. Here you go. All right, fix. All right, test it. Oh, there's another bug. And you go like back and forth for 3 weeks. And then finally all the bugs are fixed, and then we merge into master. And then 1 day later, oh, we've got some more bugs, and we've got to do that all over again. That's very cost ineffective, it's very time poor, it's not what you want. So what happens in DevOps is the development and the operations get put together. So as a software engineer, you are responsible for writing the code, testing it, fixing the bugs, all in one go, and then you just go straight into master. So this goes from being 3 weeks to like 3 hours. That's DevOps. Consolidation of development and operations, and continuous integration forms one part of the DevOps process. More broadly, it's a set of practices, tools, and a cultural philosophy that's essentially about removing this idea of, okay, I do this and I give it to you, and you do this and you give it back to me, and this sort of manual movement of things where we automate a lot of stuff and we consolidate roles and responsibilities by having the engineers essentially do their coding. This is the DevOps sort of symbol. You might see it come up. We're really interested in this sort of building and testing part as opposed to the rest at the moment, but as you do more of the topics in this course, you'll cover some of this other stuff as well. All right, so to answer your question, why continuous integration? Risk, not risk. Basically, if I didn't have the pipeline, you have to run npm test, npm type check, npm lint every single time you commit and push your code. That's really annoying and really laborious, and so we can get the computer to do that for us. So what it is about is making sure that every single piece of code that ends up on your master branch is green tick, verified. We know that, hey, it's gone through type checking, it passed the test, it passed the linting. What that gives us is this thing called assurance. So when we talk about risk, we talk about assurance. And assurance is basically saying, yes, I can kind of sleep at night knowing that I didn't forget to run type check before I submitted my 1531 project, because the pipeline passed. Pipeline ran it for me. Whoops, I forgot to run the linting. I'm going to lose like 0.005 marks. It's okay, pipeline ran it for you. This is what I said before of it runs in a standard environment. So even if it works on your computer, the pipeline will give you the assurance that it works in any standard environment. And what it is really also about is, okay, we've got this automated checks, we've got the green ticks, but it's also about the fact that this process of continuously integrating means that you are minimizing risk because you are doing lots of little changes rather than lots of big changes. This is you and your team doing your 1531 project. Because the complexity comes from, well, now you have, okay, 3 people working on one project. That's a lot more than one person. So what if you change something and you change something and you forgot to talk to each other, and so something breaks and neither of you knew? The CI pipeline picks that up for you. This becomes all the more pertinent the more developers you have. So it's about working in a team and working on this sort of very collaborative element of software engineering. On the way here, I was talking to Yu Chao about the course, and she said, "Oh, we're going to make some changes, at some point in the future." But she said, what we don't want to do is we don't want to rewrite the course from scratch in 25T1, because the greater the changes, the greater the risk that it'll go wrong. And I've seen this firsthand in many CSE courses where I said, let's rewrite this course from scratch, and then that term, the students, they had some problems. The students didn't like it very much, mainly because the inertia was so big. So it's the same thing in courses as it is in software engineering, where the more code that you change in one go, the greater the risk of it breaking. I'm going to talk about CrowdStrike in a second, But before that, I'll tell you the story of when I broke the staging environment. So we have different environments for code. Production is the one you don't want to break. Staging is the one right before production. I merged in a pull request, which is the same thing as a merge request, that changed, it deleted 8,000 lines of code. Don't ever do that. That's a bad idea. Because and it was on a Friday afternoon as well, and so I thought, okay, yeah, we'll just merge this, it'll be fine. It was deleting a bunch of stuff, it was removing a bunch of stuff that I thought was old and wasn't used, but turns out it actually was used. Anyway, it got to the staging environment, and finally I was like, oh, this is probably a bad idea. Luckily it didn't get into production. 8,000 lines of code in one PR, don't do it. Bad idea. Split the PRs up into smaller incremental changes that are easier to manage and ensure quality on. So I was thinking about CrowdStrike, and I was going to say this in the previous lecture, but CrowdStrike, you guys remember, was in July, where they had this big outage, lots of blue screens everywhere, because all these companies used CrowdStrike in their software. Do you know what the actual error was? Yes? It was a null pointer access. That's like you guys in your 1511 assignment. That happens in the real world, and I don't know if anyone died as a result, but it's like this is what I mean by risk and safety, and this is why we test and do type checking and all this kind of stuff. Obviously, their tests weren't good enough. The other thing about CrowdStrike was that their null pointer exception was on a piece of infrastructure. So let's say that the people making the slides app kind of messed up this button, and they messed up. They merged some code, and this was broken. This is not a very big impact because if I can't click this button, I don't really care. But if they merge in a change and that messes up their whole configuration in their infrastructure, then everything goes down. So it's about the areas of code that your change impacts more so than the number of lines of code. Basically what I'm trying to say for this is when you do a merge request, keep it nice and small, because then it's easy to review and it's easy to make sure that you won't accidentally break everything. In COMP1531, I don't know if they still do this, but we would actually take marks off people for having merge requests that were too complex, because you've done like 30 files changed in this PR, and we would mark based on the PR. So it was like, this is too complex, you've got to keep it nice and simple. I don't think you guys have that in this course, but what I'm trying to get across is the smaller, generally the better. Here's an example of a good merge request. I made 2 changes, modified the CI file, and then add a new Python file. This is a bad one. This guy thought it would be a good idea to commit his node modules. He was sitting there for a while as they committed. So this is bad. The 115 plus, don't do that. So continuous integration is all about making small changes and merge it in straight away. PR takes 3 hours, bang, next one. What about at a larger scale? So now I'm going to talk about CI at Atlassian. How much time do I have left? Oh, heaps of time. So we work in one repository where there are over 1,000 developers all merging in code changes at the same time, and has multiple products in it, has lots of engineers working on it. There's entire teams whose job it is to maintain the CI infrastructure for this repo. This is when continuous integration becomes even more important. You can see, this is kind of hard to see, but these are all the commits on master within the span of about 3 hours. And this was I took this at like 7 o'clock this morning. This was before people started work. This is the amount of stuff that's going on inside this huge, we call it a monorepo, because all of the code is in one place. So as software systems get larger, these continuous integration checks make sure that, because your little change might affect something over here, but you don't know that because the software is so complex. So all these things have got to run. This is a CI pipeline that I work with. You know how we had 2 checks? We had static verification, dynamic verification. This is what has to run on every single piece of code that I merge into my master branch of work. So we have that. We have type checking. Look, we have unit tests. They've just split it up into several steps. They have integration tests. They've got linting, which you'll talk about soon. So all these things are part of this, software engineering process, which everyone does every day in their jobs. And that is all I have to say about CI. Was there anything you wanted to add on anything I said?
Like in 1531 particularly, we'll start to use pipeline from iteration 2, and you do not need to play too much with pipeline. We'll set up the YAML file for you. You only need to add like 1 or 2 lines. But the key idea of this lecture is make sure that you know what is pipeline. know how it works and you know why we are using it. And we won't do too much with it in the major project.
It's a very good thing to know, and as you do more, like as you make your own, like I would really encourage you to spend time on personal projects and play around with the CI, play around with that configuration stuff, because a lot of stuff, like some people's jobs is just making pipelines. A lot of my job is to do that as well, where it's less about building features and more about building infrastructure so other people can build features on top of that. Fantastic. Thank you very much. You got the socks for the good question, and I have one more pair of socks.
And we have 5 more minutes. We can have 2 questions about like working in Malaysia or working in industry. So any of you have any questions? It's a great opportunity that we have an industry guest lecturer here from a big tech company. Yeah.
How long does it usually take for all that to finish?
The question was, how does it normally take to have all those finished? You mean the pipeline?
Yeah.
Okay.
This one takes about half an hour. I think we have a timeout on the whole pipeline, so that if it takes more than 40 minutes, it'll automatically fail. Sometimes we exceed that because we have steps that are really, really slow. You can actually see it if you look closely in here, where it's like 12 minutes. This one was pretty fast, actually. 24 minutes. Yeah, but then this is actually only one set of pipelines that needs to run in there's like 10 different pipelines because that's only one product in the whole monorepo. There's a lot of stuff. So short answer, it takes me about, on average, 3 hours to get through a simple code change, because something will usually fail and I have to do it again.
Yeah, so in 1531 we also have set time out. So if you have 2 large testing staff, you may also be like failed because of timeout. Yeah, question.
When you're looking through the merge requests, do you just visually review them or do you test them yourself in a way? You said that you have like 3 merge requests waiting for you when you get to work. Do you just like look at it or do you run the code?
So the pipeline will run on the merge request automatically, and then someone else will do a code review and they'll make sure that the change is, up to their standards.
Yeah, so in 1531 again you do code review of each other. Yeah, question.
With when you're working in like a large company, how do you sort of handle merge conflicts?
Oh, good question. So in a large company, so how do you manage merge conflicts?
The same way you do for your 1531 project, where you yell at the person. No, you don't yell at them. Usually one person, it's very, very rare that 2 people are working on the exact same thing. Mm-hmm. If you have, that probably means you've messed up your teamwork, right? You need to make sure you do all your stand-ups and your agile stuff correctly. Mm-hmm. So that I'm working on this feature and you're working on this feature. Maybe we work in the same file of code and maybe there's merge conflicts, but that's when it's good. Sorry, I'll move next to the camera.
Yeah.
That's when it's good to... This is really tripping me out, where it's like a minute behind.
Yeah, you can just keep it.
Sorry. That's when you just have to talk to the other person, basically.
Yeah.
Usually it's 2 people, we're working on the same file. Okay, what are your changes? What are my changes? We do all the git, fixing the merge conflicts, push and keep going. It's usually very minor. Often there's so much code there to begin with that you won't even be touching the same things.
Okay, so communication is the key. So we'll talk about the last question from online, from Amin. My question is, who makes the test in your company? The software engineers themselves or people who only write tests?
The software engineers write the tests. So the other company that I was talking about that make tests, or that do the QA testing, that's a very different setup. If you're a software engineer at Atlassian and most big tech companies, you will write tests yourself. So just like you guys, when you do your, let's say you have to implement, create a Kahoot? What do you guys do?
Kahoot.
Yeah, you create a Kahoot. So you write the test first, because test-driven development. You write the code, git commit, git push, run the CI, code review, merge, bang, next feature. Same thing as how it works at Atlassian.
Yeah, so 1531's major project is really designed based on how industry work. Okay. Yeah, that's all for today. Let's thank you for next great lecture.
Thank you very much for having me. If you want to grab some merch that is on the table, feel free, please only take one thing. Help yourself with some stickers. First things, best dressed.
Thank you so much.
No worries.
I stopped streaming.
Thank you so much.
No worries.
Hope to see you in like the like
You'll see like old stuff of me in that, but